We live in a world awash in plastic. Every corner of our planet, from the deepest oceans to the highest mountains, is touched by this pervasive material. It's cheap, it's durable, and it's everywhere. From the packaging of our food to the clothes we wear, plastic has become an integral part of our daily lives. But this versatility comes at a cost. The very qualities that make plastic so useful also make it a persistent pollutant. Plastic pollution is choking our oceans, filling our landfills and harming wildlife. Marine animals in particular suffer greatly, often mistaking plastic for food. We need a solution, and nature may hold the key. By turning to the natural world, we can find innovative ways to address this crisis. Bioplastics made from plants offer a promising alternative to traditional petroleum-based plastics. These materials can break down more easily and reduce our environmental footprint. Imagine a future where our plastic bottles and bags could simply decompose, returning to the earth without a trace. This vision is within our reach. This isn't science fiction, it's the potential of bioplastics. Researchers and companies are already making strides in this field. These innovative materials are derived from renewable resources like corn and sugarcane, offering a more sustainable approach to our plastic problem. They represent a shift towards a circular economy. By harnessing the power of plants, we can begin to reduce our dependence on fossil fuels and create a cleaner, healthier planet. Together, we can turn the tide on plastic pollution and pave the way for a sustainable future. The journey from plant to plastic is a fascinating one. Take corn, for example. Corn is not just a staple food, it's also a key player in the bioplastic industry. The process begins with wet milling, a technique used to separate starch from the corn kernel. This step is crucial as it isolates the starch needed for the next stages. This starch is the building block of our bioplastic. Without it, the entire process would come to a halt. Next, the starch is converted into sugar, which then undergoes fermentation, much like brewing beer. This transformation is essential for creating the base material. This fermentation process produces lactic acid, a vital component in the creation of bioplastics. Finally, the lactic acid is polymerized, a process that links small molecules together to form long chains. These chains are what give bioplastics their unique properties. The result is polylactic acid, or PLA, a common type of bioplastic. PLA is used in a variety of products, from packaging to disposable cutlery. Sugarcane-based bioplastics follow a similar process, highlighting the versatility of this technology. This demonstrates how different plants can be utilized to create sustainable alternatives to traditional plastics. Bioplastics offer several advantages over traditional plastics, making them a promising alternative for a sustainable future. Firstly, they are made from renewable resources such as corn, sugarcane, and other crops. Unlike fossil fuels, which take millions of years to form, plants can be grown and harvested year after year, providing a consistent supply. This means that bioplastics have a much smaller carbon footprint, significantly reducing our impact on climate change and promoting environmental sustainability. Secondly, many bioplastics are biodegradable, which means they can break down naturally over time. Under the right conditions, they can decompose naturally, breaking down into harmless substances, thus reducing pollution. This is in stark contrast to traditional plastics, which can persist in the environment for centuries, causing long-term damage. Bioplastics also offer the potential to reduce our reliance on landfills, which are often overflowing with plastic waste, contributing to a cleaner planet. While bioplastics hold great promise, there are still challenges to overcome. One major hurdle is cost. Currently, bioplastics are generally more expensive to produce than traditional plastics. This is due in part to the complex manufacturing process and the relatively small scale of production. However, as technology improves and demand increases, the cost of bioplastics is expected to decrease. Another challenge is land use. Growing crops for bioplastics requires land, and this could potentially compete with food production. It is crucial to ensure that the production of bioplastics is done sustainably without displacing food crops or contributing to deforestation.